We think that at the beginning of time, there was this perfection of 10 or 11 dimensional hyperspace, but these other dimensions curled up, so small that atoms cannot leak into these higher dimensions.
So these are the kinds of that look from a distance as if they're one-dimensional, but when you get very, very, very small on scales that are much, much smaller than an atom, they actually would curl around each other and be like a straw.
That's right. So that the universe we see around us really is hyperdimensional, but we can't see it because these other dimensions have curled up. They're too small to be observed.
Compactification is the word that I think string theorists use.
That's right. If I have a tabletop exists in 2 dimensions, but I can roll it up like in a cigarette, roll it up, and then I see this 1-dimensional thing, which is actually 2-dimensional if I get very close with a microscope. So we think that these higher dimensions are all around you, in your body, in your living room. The pond touches the 3rd dimension at every point. So if I have a pond and we are the fish swimming in the pond, and you ask the fish, where is the 3rd dimension? The answer is everywhere.
All right, now we have, that's on the microscopic scale. What about large extra dimensions that seem to be talked about now in some theories of cosmology?
Well, strings can only vibrate in 10 dimensions, but in the 90s, there was a revolution that it turns out that if you add an 11th dimension, one more dimension, then membranes can exist. Not just little strings, but beach balls and golf balls can vibrate. And perhaps our universe is a membrane, in which case perhaps some of these dimensions could be large, perhaps even infinite. So once you go from the 10-dimensional world of strings, where these dimensions are very tiny, and go to an 11 dimensions, then you're talking about a whole new picture, a picture whereby some of these dimensions could be huge. And that may even explain why gravity is so weak. Gravity is a very weak force. Perhaps gravity oozes, escapes into these higher dimensions, and that's why gravity is so weak.
This so-called hierarchy problem, which gravity may be 10 to the 39th or 10 to the 40th times smaller than the electromagnetic force. It seems if these two are fundamental forces, to have such a vast difference in scale doesn't seem to make sense.
That's right. I could put sheets of paper on the table, comb my hair, and you do this in elementary school, pick up the sheets of paper. Well, I just defied gravity. The Earth weighs 6 trillion kilograms. I defied 6 trillion kilograms with a comb by picking up pieces of paper with the electric force. That's how weak gravity is. And perhaps these higher dimensions is due to the fact that space oozes, gravity oozes into these higher dimensions.